So this lesson is going to be on limits with square roots. So let's take a look at the following problem. If I want the limit as x goes to 5 of the square root of x plus 4 minus 1, what do we do here? Well, the first strategy is to check to see if when you plug it in, you get a reasonable answer. So the limit of the sum is the sum of the limits. So I certainly could say this is the limit as x goes to 5 of the square root of x plus 4 minus the limit as x goes to 5 of 1. Now, what is the limit as x goes to 5 of the square root of x plus 4? As numbers get very, very close to 5, x plus 4 gets very, very close to 9, so this whole thing gets very, very close to root 9. Just plugging in the value, right? Plugging in 5 for x, maybe I should put that in there and I should say square root of 5 plus 4, right? Over on this side, as x gets close to 5, what does 1 do? Well, if you want to visualize that for a minute, let's go to Desmos. If I look at the equation y equals 1, there it is. As x values get close to 5, what do the y values do? From the left, the y values are always 1. From the right, the y values are always 1. So indeed, as I approach 5 of 1, the y values always approach 1. The function always approaches 1. So we get this, root 5 plus 4, root 9, minus 1, 3, minus 1 is 2. Now, does that surprise me at all? It shouldn't. Let me go ahead and graph that on Desmos and see what that looks like. So if I put in that function, let's call it f of x equals the square root of x plus 4 minus 1. And as I get closer and closer to 5, what do the y values get closer and closer to? And you can see, indeed, they get closer and closer to 2. The fact of the matter is 5, 2 is on the graph because this is continuous. If it's continuous, if I plug the number in, I get the same value. So nothing too surprising about this. This is our simplest case, but they can get more interesting. So if I look at the following, if I look at the limit as x approaches 9 of x minus 9 over the square root of x minus 3, x is approaching 9. If I try to plug in 9, if I plug in 9 on the top, plug in a 9 for x, I get 9 minus 9 on top. On the bottom, I get square root of 9 minus 3. And that's what makes this interesting. Because what I have on top is 9 minus 9 is 0. What I have on the bottom is 3 minus 3. And we get 0 over 0, which is a different kind of case than 1 over 0 or 5 over 0. Because 0, 0 is undetermined. This is an indeterminate case. When you have an indeterminate or an undetermined case, you may indeed have a limit. It's worth your while to go ahead and see if you might have one. So what tool are we going to use here? Limit as x approaches 9 of x minus 9 over root x minus 3. The tool I'm going to use is to rationalize the numerator. So multiply top and bottom by root x minus root x plus 3. Root x plus 3 here. Root x plus 3 there. So we get the limit as x approaches 9 of something. Something is on top, something is on the bottom. What is on the bottom? Let's do that first. Root x minus 3 times root x plus 3. Root x minus 3, root x plus 3. Root x times root x is x, plus 3 times root x, plus 3 root x, negative 3 times root x, negative 3 root x. Negative 3 times positive 3 is negative 9. Put all that together and I get, those disappear, I get x minus 9. So what's on the bottom is x minus 9. What is on the top is x minus 9 times root x plus 3. And here you will see what's going to happen is the x minus 9 divides out. X minus 9 divides out here, x minus 9 divides out here. So what I wind up with is the lim as x approaches 9 of the square root of x plus 3. So let's plug the 9 in. Plugging the 9 in for x, let's see if that works. We get square root of 9 plus 3, which is 3 plus 3, which is 6. Now I'd like to check that somehow. So let me go ahead and check that by plugging this into the graphing calculator. X minus 9 over root x minus 3, and see what happens as I get closer and closer and closer to 9. So I'll pull up the graphing calculator. Y equals, upstairs in parentheses, x minus 9. Divided by downstairs in parentheses, square root of x minus 3. And we want to see what happens as we get closer and closer to 9. So I'm going to go to the table, second table set. We could go automatic first, and then I'll go to ask second. So just do it automatically, clear the previous table. Second table set ask, I can put in my own numbers. And I'm supposed to be getting closer and closer to 9. So let's try that. So 8.9. 8.99. Could you believe that from the left we're getting closer and closer to 6? Sure looks that way. And from the right, 9.1, 9.01, 9.001. And you certainly can believe that's getting closer and closer to 6, which makes us feel pretty good about our answer here. So our tool here was to rationalize the denominator, but that's not always the tool that we use for those interesting cases. What if I have the following? If I have the limit as x goes to 5 of root x minus 1 minus 2 over x minus 5. So we always try to plug it in first and see if we get something useful. So plugging in 5, we have root 5 minus 1 minus 2 over 5 minus 5. Root 5 minus 1, root 4 minus 2 over 0, which gives me 2 minus 2 over 0, which gives me 0 over 0. So again, we have another undetermined form, or indeterminate. So we haven't determined what that value could be. It really could be many different things, conceivably. So we're going to need to do some algebra to find out what it is, if that limit exists, what that value will be. So what we do here, instead of rationalizing the denominator, we rationalize the numerator. So this is what we get. Limit as x goes to 5, and we have root x minus 1 minus 2 over x minus 5. So I'm going to put those in parentheses just so we see them as multiple pieces, as two terms. Multiply top and bottom by the conjugate, this time of the numerator, conjugate of the top, root x minus 1 plus 2, and on the bottom, root x minus 1 plus 2. So that's what we've done, multiplied by the conjugate on top, multiplied by the conjugate on the bottom. So what is on the top? What does that become? If I'm looking at this, I like to use a multiplication box to visualize that. Students tend to prefer FOIL. But whichever you use, we need to multiply these two expressions. So we get root x minus 1 minus 2, root x minus 1 plus 2. So root x minus 1 times root x minus 1 is just x minus 1. 2 times root x minus 1 plus 2 root x minus 1. Negative 2 times root x minus 1. Negative 2 root x minus 1. Negative 2 times positive 2 is negative 4. So if I add all of these together, you will notice that these cancel. And the result is x minus 1 minus 4. Which gives me what? Which gives me x minus 5. So this times this is just x minus 5, and you'll see how that will divide out with what's on the bottom. So we've done that multiplication. Move that aside. And now we'll rewrite this as the limit as x goes to 5. Multiplying those things on the top again, our result was x minus 5. So the top now becomes x minus 5. I'm not going to multiply those things on the bottom because I want to see how the x minus 5 divides out. X minus 5 here. Root x minus 1 plus 2. So the x minus 5s go. Now I have the limit as x approaches 5. Upstairs is just 1 over the square root of x minus 1 plus 2. At this point, let's plug the 5 in for x and see what we get. 5 goes in for x. We're going to try to plug it in and see if we get a value, which is 1 over the square root of 5 minus 1 plus 2. Which is 1 over root 4 plus 2, which is 1 over 2 plus 2, which is 1/4. And I like to check, so I'm going to go all the way back to my original, and I'm going to plug this into the graphing calculator and see if I get close to 5, do the y values get close to 1/4. So let's go back to the graphing calculator, clear out what we have there. Clear out what we have here. The numerator is supposed to be square root of x minus 1 minus 2. So in parentheses, square root of x minus 1 minus 2 divided by, in the denominator, I need x minus 5. So again, in parentheses. And I want to see what happens as I get closer and closer to 5. Remember, we're looking at the limit as x approaches 5. So from the left and from the right, what's happening there? So we'll go to our table. We'll do automatic first to clear what's there before. Do second table just to see it. And then we're going to change it, of course. Second table set ask on independent variable. And we're going to get close to 5. So second table, 4.9. And I expect it to be getting close to 1/4. All right, 4.99. Close to 1/4, 4.999. Close to 1/4. Not really 1/4, though it looks like it might be 1/4, but it's really 0.2500156. So close to 1/4. From the left, it's heading to 1/4. How about from the right? 5.1, 5.01, 5.001. But if I plug in 5, what happens at 5 doesn't matter, because if I plug in 5, what does the computer give me? It gives me an arrow. There is no point at 5. So that indeed is going to be our solution. We're going to get our answer of 1/4 for that. Okay, let's do one more problem. Like this, we are going to be dealing with the definition of the derivative. So we may want to look at something like the following. The limit as h goes to 0 of the square root of x plus h minus the square root of x over h. So our usual rule is we're going to plug in zeros and see what we get. If I try to plug in, what happens? If I try to plug in, if I plug in 0 for h upstairs, I get square root of x plus 0 minus square root of x, because that's not changing, h is changing. H goes to 0 downstairs, 0 downstairs. So I get root x minus root x over 0. I get 0 over 0. That's the case that's interesting. So again, this is undetermined. So it may have a limit. It may have a limit. So we're going to go ahead and actually do some analysis here. So let's take a look. We're going to rationalize the numerator again. Limit as h goes to 0. Root x plus h minus root x over h. Multiply top and bottom by the conjugate, which will be root x plus h plus root x here, root x plus h plus root x there. Then we need to multiply. So I'm going to use my multiplication box thing again and see what I get. So this times this is what I'm interested in primarily, right? These two pieces multiplied by those two pieces. And what do I get? What do we get? Let's take a look. We have root x plus h minus root x, and root x plus h plus root x. So root x plus h times root x plus h is x plus h. Plus root x times root x plus h would be root x times root x plus h. Minus root x times root x plus h is minus root x times root x plus h. Notice those will cancel nicely. But plus times minus is minus. Root x times root x, if x is positive, it's going to be x. If otherwise, absolute value of x. Let's assume for our discussion that x is a positive number. So what do I get? These things go away. Actually, it is, of course, it is negative x, regardless. This goes, so I get x plus h minus x. So upstairs, the result is just h, and notice that will divide out nicely with the piece over here again. Root x plus h times root x plus h, x plus h. Root x times root x plus h, root x times root x plus h, negative root x times root x plus h, negative root x plus h, negative root x times positive root x, negative root x times root x is x always. X plus h minus x is h. So upstairs is h. And we have the limit as h goes to 0. After all that, upstairs is just h. Downstairs is h times this stuff. And you will notice the h's divide out. The h's cancel. So now I have the limit as h goes to 0 of 1 over root x plus h plus root x. H goes to 0. So now I'm going to go ahead and I'm going to plug that 0 in for h. Make sure you're paying attention to the variable. So it's 1 over root x plus h is now 0 plus root x. And we get 1 over root x plus root x. Oops, 1 over root x plus root x like this, which is 1 over 2 root x. And that will do that for this lesson.